So I welcome you once again to Peg Tutors, and I'm really glad you're here. Please, I want you to click the subscribe button so that anytime we upload any video, you'll be the first to be notified, and also ring the bell. Thank you very much for following us up. Today, we are going to be talking about a topic in physics, which is simple AC circuit. This has been a major problem to students during calculations and all that. So they find it difficult most times to do some simple calculations under simple AC circuit. I'm going to try my best as much as possible to break the simple AC circuit down just a little bit. Now, let's start from the simple AC circuit. What is the simple AC circuit? AC simply means alternating current. Yeah, alternating current circuit. Before now, we have two currents. We have the DC, we have the AC. DC is the direct current, the current that comes from batteries and, chemicals and all that. Those are the DC current, but this is AC current. Alternating current, a type of current that is produced from the rotation of coil in a magnetic field. Because of the nature of the production of the AC current, it is said to be sinusoidal in nature. Sinusoidal in nature, which means it flows like a wave. It has a wave-like flow up and down with time. So the current of the AC circuit and the voltage, the current of an AC and the voltage of the AC has this, sinusoidal flow or type of motion with time. Now, at this point, we have what we call the peak current or the peak voltage. The peak current or the peak voltage, which is the maximum amount of current and the maximum amount of voltage of an AC. Now, in DC, you have a formula that governs the whole of the DC. And that formula is the Ohm's law, derived from the Ohm's law, which is V equal to IR. This is a formula that governs the DC. But in AC, it's not like that because, like I said before, AC is sinusoidal. That sinusoidal nature of an AC current makes its formula quite different. So in AC, the current of an AC is given instead of V equal to IR, where I equal to V over R and R equal to V over I. In AC, the current of an AC circuit is represented or is given as IP sine WT, where the IP is the peak current of an AC, and then the W here is omega, the velocity, angular velocity, because the sinusoidal nature of it makes it move in an angle. So the velocity of the flow of current and voltage is represented with an angular velocity, W. Remember that this angular velocity as well can also be given as 2 pi f, okay, where f is the frequency of the current. All right, now the voltage of the AC also is also given as Vp sine Wt. Of course, everything still remains constant, where Vp is the peak voltage of the AC and W also is omega, which is also the same thing as 2 pi f. Then your T is time. So this is the actual representation formula for the AC current, and this is the formula for the AC voltage. Now, you also have some devices that you can connect in an AC circuit that would reduce the current or reduce the voltage. In this case, it doesn't reduce. Either it makes the current move faster than voltage or it makes voltage move faster than current. And these devices are, you have the resistor, is one device. You have the capacitor as well. Then lastly, you have the inductor. So any of these connected in an AC circuit would either reduce the flow of current or reduce the flow of voltage. In this case, the voltage either move faster than the current by a certain angle called the phase angle. So we say that the current and the voltage are no longer in phase, which means they are no longer in the same flow of angle. Thank you. So we are going to be looking at If you connect the resistor, what is the effect in the AC circuit? If you connect the capacitor, what is its effect in the AC circuit? And if you also connect the inductor, what is its effect in the AC circuit? So we're going to start from the resistor in an AC circuit. So let me put resistor in AC circuit. Now, let us assume, okay, let's put it out. So let us assume that in an AC circuit such as this, by the way, this is the symbol of an AC. So if you see any symbol like this, it indicates that this is an AC source. Now, this is our symbol of resistor. And then this. So just imagine that you connect an arrow in the AC circuit of a current flowing towards this direction with a voltage as well, where AC voltage flowing towards that direction. What is the effect of this resistor in the AC, in this AC circuit? Now, the resistor actually does not have any effect on the AC circuit. Yes, it doesn't have any effect, which means even if you connect the resistor, the current and the voltage still moves in the same phase. They are still maintaining the same angle of flow. So in that case, remember that from Ohm's law, V equal to IR. Okay, our R still remains the same, which means at this point we have voltage of the resistor in an AC circuit will give us peak current of AC circuit then times the R. So if you want to calculate the voltage flowing in, it is peak current times R. So there is no actual effect of the current of the resistor in an AC circuit. All right. Now let us go to the next. So you have this as L, inductor, while the current flow, AC current and AC voltage are here flowing directly into the inductor. Now the question is, for an inductor, what is the effect in an AC circuit? If an inductor is connected in an AC circuit, one effect it has in the AC circuit is that it makes the current to lag the voltage, which means current is backward while voltage goes ahead by 90 degrees. In other words, in this case, when you connect an inductor, current becomes I, which is the AC current, becomes I equal to peak current sine WT, the same. While the voltage, remember we said voltage will lead current, or current will lag voltage by 90 degrees. So voltage will be peak voltage sine open bracket WT, but because voltage now is ahead of current by 90 degrees plus an additional angle 90 degrees. So this becomes the formula at this point. Now remember that from Ohm's law, V is equal to IR. Now this R now is no longer what we are considering. We are considering the inductor, not R. Okay, so we change this inductor. Now the question now is, what is the opposition that the inductor is offering to the AC circuit? Now this opposition is what we call reactance. Yes, it's no longer resistance, but it becomes reactance. So the opposition of an inductor to an AC circuit is called inductive reactance, while the opposition of the capacitor in an AC circuit is called capacitive reactance. So instead of putting R there, you put the value for the inductive reactance. Reactance is X in this AC circuit, so we represent it with X. Okay, now XL now tells us that this is the inductive reactance, the opposition of the flow of electric current in an AC circuit. So our V becomes the voltage, or the voltage across the inductor becomes peak current times XL, which is the inductive reactance. Okay, now how do we calculate this? Of course, the voltage will be given to you, the voltage of the inductor. The current, peak current, will also be given to you. Probably the only thing that you will be asked to find is this XL, and XL is calculated using XL equal to omega L. Of course, we have told you what omega L is. Omega is velocity of the current and the voltage. Where velocity of the current, where W is equal to 2 pi F. And L here is the value of the inductor so connected. The value of the inductor. So you'll be given the value of the inductor. Inductor, the SI unit of inductor is Henry. So they will give you the value of the inductor there. Why you use the omega L to find your inductive reactance. If this is clear, let us take a question to see what we can do. Okay, so let's take this question. It says, if the current amplitude in a pure inductor in a radio receiver is 120 microamp, it says when the voltage amplitude is 3.0 volts at a frequency of 1.2 megahertz, calculate I, the inductive reactance, and II, the inductance. So where do we start from here? Now, first of all, you have to bring out your parameters that are given to you so you can know the way forward and way ahead. So parameters given to me here are 1, the current, microampere. Remember, current is microampere. So we have 120 microampere, which is the same thing as 120 times 10 raised to power minus 6 amp. Okay, then you have your voltage given to you as 3.0 volts. That one is free. Then you have your frequency given to you as 1.2 megahertz. Normally this is supposed to be in hertz, so megahertz should be like 10 times 10 raised to power 6. Okay, now we have I think that's all given to you. So you now say therefore, first thing they ask you to find is inductive reactance, which is XL. Okay, which is XL. So the question is, how do I find XL? Knowing fully well that they gave me only voltage and the current and the frequency. Remember what I said about this formula, VL equal to XP, which is, IP, peak current, times XL. If you make XL, sorry, the formula, you can say therefore, from VL, which is the voltage of the inductor, so connected, is equal to the current times the XL, which is the inductive reactance. Now remember that my inductive reactance here, if I make it so, the formula will be VL over I, which is equal to, my VL is 3. Yeah, all over I is 120 times 10 raised to power minus 6. If you calculate this properly, this will give me 2.5 times 10 raised to power 4 ohms. So this is my answer. Yes, reactance, remember, is an opposition. So resistance, it is ohms. That is the first one they asked us to calculate. So it is 2.5 times 10 raised to power 4 ohms. Then the second one, they asked us to calculate the inductance. Inductance simply means find the value of the inductor that is connected, the value of the inductor. But remember that to find the value of the inductor, you can use XL equal to omega L. Yeah, omega L. But remember that XL has been calculated already. So XL equal to omega is 2 pi F, like I said before. Then your L. L is what you are looking for. X you have gotten already. So you can say L therefore is equal to XL all over 2 pi F. Okay, so L is equal to, our XL is 2.5 times 10 raised to power 4 all over 2 times pi is 22 over 7 times, so you have your frequency, which is 1.2 times 10 raised to power 6. Like I said before, that mega is times 10 raised to power 6. So your L becomes 3.3 mega millihenry, sorry, 3.3 millihenry, if you calculate that very well. So this is how you can do your simple calculations in a simple AC circuit. So this is just the connection of the inductor and the connection of the resistor. Next, check my next video. I'm going to be talking about the capacitor. After the capacitor, we'll talk about the connection of both the resistor and the capacitor, the resistor and inductor, the capacitor and inductor, and we'll talk about when you also connect the resistor, the inductor, and the capacitor in the same circuit. Thank you very much. Please check my next video for the next lesson.